Welcome everyone in this video. Today I am going to discuss question number 201 to question number 227 of steel structures from Kurbi and Gupta book. So let's start. Question number 201. A fixed beam made of steel is shown in the figure 13.19. At collapse, the value of load P will be equal to, suppose this is the fixed beam under this load. This is a point load acting at the mid span of the beam. So we know plastic hinge will form at these two fixed position and at the point where point load acts, and at same point section also changes. So plastic hinge will form at here and at here. So the collapse diagram will be like this by beam mechanism. If this angle is theta, this angle is theta, so this angle will be 2 theta. So external work done will be equal to load into deflection. Load P into deflection L by 2 into theta. This length is L by 2 and this length is L by 2, right, of this load. Okay, so we can write load P into deflection L by 2 into theta. So PL by 2 into theta. This is equation number 1. And internal work done equal to moment into rotation. So here MP into theta, here MP into 2 theta, but here 2 MP into theta. So total internal work done will be equal to 5 MP theta. That is equation number 2. So for the principle of virtual work, if we equate equation 1 to equation 2, we will get the collapse load P equal to 10 MP by L. Question number 202. The ratio of collapse load of a propped cantilever of span L carrying a UDL throughout the span to that of a simply supported beam carrying the same load is. So when propped cantilever beam subjected to a uniformly distributed load W, the plastic hinge will form at a distance 0.414 L from this far end. Suppose at this end. So at this end, the collapse load will be under this load will be 11.656 MP by L, and if a simply supported beam subjected to a uniformly distributed load W of span L and plastic hinge will only form at the middle of the beam, then the collapse load will be equal to 8 MP by L. This is collapse load W1, this is collapse load W2. So if we make the ratio W1 by W2, we will get 1.457. Option A is right answer, 1.457. Question number 203. The elastomeric bearing pads are favorable to the steel roller bearings since they do not require any periodical maintenance. Option B is right answer. Question number 204. To transform an indeterminate frame with a degree of indeterminacy R into a determinate one, the number of plastic hinges required is R, where R is the degree of indeterminacy, and the number of plastic hinges required for collapse is R plus 1. Option C is right answer. Question number 205. The notching in a simply supported timber beam of span L and depth D should be restricted to the region L by 6 or 3D from the supports, whichever is less. Option D is right answer. Suppose this is a timber beam. Okay, so for connecting purpose we have to notch that beam or the member. So this portion is notching, length, and this is the depth of notching. Question number 207. In a composite construction, interface slipping is prevented by using shear connectors. Option A is right answer. Question number 208. If capital A be the area of cross section of a bar, the gauge length for measurement of the ductility will be 5.65 into root over A. Option A is right answer. In a tensile test on a bar, gauge length means the length over which extension is measured. Question number 209. High yield deformed bars have a percentage elongation less than that of mild steel. Option C is right answer. Question number 210. The effective length of a structural steel compression member of length L effectively held in position and restrained against rotation at one end but neither held in position nor restrained against rotation at the other end is 2L. Option D is right answer. Question number 211. In a simplified design of angle iron purlins, which one of the following assumption would not be valid? Option B will not be valid. Bending moment about the minor axis is considered. No, bending moment about major axis is considered. Question number 212, match list 1, which is the type of connection with list 2 type of beams, and select the correct answer using the codes given below. List 1, capital A, semi-rigid connection to allow small end rotation and transmit appreciable moment. Option 2, in list 2. In list 1, capital B, framed connection, that is equal to 4 when a beam is connected to a beam by or stanchion by means of two angles riveted to them. Next, capital C, in list 1, flexible connection to permit large angles of rotation and to transmit negligible moment, that is flexible connection. So C equal to 1. Next, option capital D, in list 1, seated connection when a beam is connected to a beam or stanchion by means of an angle at the bottom of the beam which is soft riveted to the beam and the angle at the top of which is field riveted. Seated connection capital D in list 1 will be equal to option 3 in list 2. Number 213, for two plates of equal thickness, full strength of fillet weld can be ensured if its maximum size for squarage is limited to 1.5 mm less than the thickness. Option A is right answer. Question number 214. A fixed beam is shown in the figure 13.20. The plastic failure load for this beam will be. Suppose this is the fixed beam. The load, point load acts here at a distance L by 3 from this end to middle of this beam will be 2 MP and up to here to this support will be MP, 6 moment capacity. So first we have to know the plastic hinge will form at this fixed position and at the point where point load acts at here and at the point where section changes. So here because moment capacity changes from 2 MP to MP, so here plastic hinge will form. So under this load when plastic hinge will form, the collapse diagram will be like this by beam mechanism. This angle is theta 1, this angle is theta 2. So this angle will be theta 1 plus theta 2 by the geometry. So we can also write L by 3 up to left of this load, the deflection will be L by 3 into theta 1 which is equal to right of this load L to 2/3 L into theta 2. So we will get theta 1 equal to 2 theta 2. So external work done will be equal to load into deflection. So load will be P and deflection L by 3 into theta 1. Suppose that is equation number 1. Internal work done will be at here 2 MP into theta 1, at here 2 MP into theta 1 plus theta 2 and at here MP into theta 2. Put the value of theta 1 equal to theta 2 in this equation. We will get total internal work done Wi equal to 11 MP theta 2. That is equation number 2. By the principle of virtual work, if we equate equation number 1 to equation number 2, we will get collapse load P equal to 16 MP by L. Now when the section changes under this, the plastic hinge will form at the middle. So the collapse diagram will be like this. If this angle is theta, this angle is theta, this angle will be 2 theta. So the external work done will be load into deflection L by 2 into theta. So PL by 2 into theta, that is equation number 3. And the internal work done will be moment rotation 2 MP theta plus 2 MP into plus MP into 2 theta plus MP into theta. So 5 MP theta, that is equation number 4. So by the principle of virtual work, if we equate equation number 3 to 4, we will get collapse load for the collapse load equal to 10 MP by L. So the value of collapse load will be considered, which is the lowest, that is 10 MP by L. Option A is right answer. Question number 215. The height at which wind forces acts on a moving vehicle on a bridge deck is 1.5 meter. Option B is right answer. Question number 216. Braking force on a steel railway bridge is due to the lateral movement of the train when moving on a straight track. Option D is right answer. Question number 217. For a composite steel beam and RCC slab floor construction, shear connectors are provided to develop the composite action. Option D is right answer. Question number 218. According to Indian Railway Board, in respect of steel girders of single track span per meter of broad gauge, the impact factor for spans of 6 meter is. We know the formula for impact factor is 0.15 plus 8 by 6 plus L, where L is the span of the beam equal to 6 meter. So impact factor will be equal to 0.15 plus 8 divided by 6 plus 6. and the final value of impact factor is equal to 0.817, so close to 1. Option C is right answer. Question number 219. In a composite construction, the connection between a reinforced concrete slab and a RSG on which the slab is resting are designed for shear forces. Option C is right answer. Question number 220. A propped cantilever of span capital L is subjected to a concentrated load at the midspan. If MP is the plastic moment capacity of the beam, then the value of collapse load will be. Is the propped cantilever beam. The load acts at the midpoint, so this length is L by 2, this length is L by 2. The collapse diagram will be like this by beam mechanism. This angle is theta, this angle is also theta. Lengths are equal, so external work done will be equal to load into deflection. So P into L by 2 into theta, PL by 2 into theta, that is equation number 1. And internal work done will be equal to moment into rotation at this point MP into theta, moment into rotation at this point MP into 2 theta. No internal work at this point. Total internal work done will be equal to 3 MP theta, that is equation number 2. So by the principle of virtual work, if we equate equation number 1 to equation number 2, the collapse load will be equal to 6 MP by L. Option C is right answer. Number 221. Match list 1 with list 2 and select the correct answer using the course given below. In list 1, that is use and list 2 type of weld. In list 1, capital A, structural member subjected to direct tension or compression. Answer 5 in list 2. That is what weld. In list 1, capital B, joining two surfaces approximately at right angle to each other. The answer will be fillet weld. In list 2, capital C, in list 1, a hole is made in one of the components and welding is done around the periphery of the hole. That is the slot weld. Option answer 1 in list 2. D in list 1, pressure is applied continuously. That is seam weld. So the proper arrangement will be option C. Question number 222. In a simply supported beam of span L, each end is restrained against torsion, compression flange being the unrestrained. According to IS 800, the effective length of the compression flange will be equal to L. Option A is right answer. Question number 223. A column base is subjected to a moment if the intensity of bearing pressure due to the axial load is equal to the stress due to the moment, then the bearing pressure between the base and the concrete is. Suppose this is the column and this is the column base. Okay. If the column subjected to a axial load P and the bending moment M, okay, the axial stress will be P by A and the bending stress will be M by Z. Z is the section modulus of the base section. So both stress are equal to each other. So we can say P by A equal to M by Z equal to sigma. So suppose this point is A and this point is B. So at this point the pressure will be equal to the summation of both this stress, this axial stress plus bending stress. At this point A, the pressure value will be the difference between both this stress, axial stress and bending stress. So the pressure will be 0 at this end and this is compression because the load is compressive over the column. Option B is right answer, 0 at one end and compression at the other end. Question number 224. Consider the following statement. A grillage base is checked for bending, shear and wave crippling. So statement 1, 2 and 4 are correct. So option D is right answer. Question number 225. A welding detail is shown in the figure 13.21. The welding notation of the figure is option A is right answer. For this 8 mm weld, this is the notation, and for this divided by for 8 10 mm weld, this is the notation 75 by 100. Question number 226. In a plastic hinge, the actual distribution of the strain across the section will be as in. Option A is right answer. Question number 227. The figure 13.24 shows a portal frame with loads. All members have the same plastic moment of resistance MP. The ratio of P1 to P2 for beam and sway mechanism. So for this portal frame, the plastic hinge will form at here, this fixed position, at this fixed position, at this point, at the middle of this member, where point load acts, and at this joint. 1, 2, 3, 4, 5. So 5 possible hinges subjected to this kind of loading. The beam mechanism will be for this horizontal part and this vertical load. So collapse diagram is drawn like this. External work done will be equal to load P1 into deflection L by 2 into theta, that is equal to P1 L divided by 2 into theta, that is equation number 1. And the internal work done will be at here moment in rotation MP into theta, at here mp into 2 theta at here mp into theta. So 4 mp theta, that is equation number 2. So by the principle of virtual work, if we equate equation 1 to equation 2, we will get collapse load P1 equal to 8 mp by L. Now for sway mechanism, the collapse diagram will be like this. External work done will be load into deflection, load P2 and deflection this length into theta, L into theta. So P2 L theta, equation number 3. And for internal work done, at here mp into theta, at here mp into theta, at here mp into theta, and at here mp into theta. So equal to 4 mp theta, that is equation number 4. So by the principle of virtual work, if we equate equation 3 to equation 4, we will get collapse load P2 equal to 4 mp by L. So if we make the ratio P1 by P2, we will get the value 2. Option B is right answer.